right angle triangle, when we mark an angle A, so everything about the sides related with this angle, the side which is opposite to this given angle is called opposite, and the side which is opposite to 90-degree is always called the hypotenuse, and the side which is left is called adjacent. And we know that the ratios of sine of angle A, cos of angle A, and tan of angle A. Sine of angle A is opposite over hypotenuse, cos of angle A is adjacent over hypotenuse, and tan of angle A is opposite over adjacent. We
Okay.
also know to find the missing side, there is a Pythagoras theorem which we used. If we have a triangle which is not a right angle triangle, we use few formulas to find sometime sides or sometime angles A, B, and C. In cosine rule, it is used to find the sides and also used to find the angle. I'm just giving you a quick review about the previous knowledge. Like if we are finding a square, then the other two sides are b and c. We write them with b square plus c square minus 2 time of bc, and the angle is the angle which lies between side b and c. I mean, this is the angle. Either you also make the concept like this angle is opposite to the missing side, so we write it this angle. If all three sides are given, we can also use cosine rules to find the angle. Like if we are looking for angle A, we write cos of angle A. The side which is opposite to angle A is small a, and we write it with minus a square. The rest of the sides are B and C, so we write b square plus c square minus 2 time of bc. Then we also know the sine rule. Sine rule again, it is used to find the side and angle. If you are looking for angle, so I would suggest write angle in numerator with sine. Sine of angle A opposite to the side, sine of angle B opposite to the side, and sine of angle C opposite to the side. Or you write it A over sine A and B over sine B, and this is C over sine C. Okay.
Okay.
In AS, I call this topic a further trigonometry. This is further trigonometry. Let's have a basic of further trigonometry. We plot coordinate axis, and we plot this coordinate axis just to show that the part which lies between x and y axis is called first quadrant, and
Okay.
this is always the second quadrant, and this is third quadrant, and this is the fourth quadrant. These are the four quadrant. As we know that basic angle between first quadrant is 90, so 90 degree is an angle in every quadrant.
Yes.
Okay, so this y-axis is at 90 degree, this is x-axis is at 180 degree, and the negative part of y-axis is at 270. This is 360. So when you start with this part, so we say that this is zero angle. We
Okay.
say that all or positive. this is sine is positive, and in third quadrant only tan is positive, and in the fourth quadrant it is cos which is positive. All positive means, when we say all positive, it means we are taking sine positive, we are taking cos positive, and we are taking tan positive. You must be thinking why all these values are positive. If you use any acute angle, you know that in first quadrant we have acute angle. We write sine of any angle which is acute. Let us suppose I'll write sine of angle 30. When I use the calculator and get the answer, I'll get this answer, and this answer is positive. So any acute angle with any ratio, sine, cos or tan, it will give you some answer which is positive. So tan of 30 will give you 1 over under root 3. It's positive sign. At the same time, if we consider the angle in the second quadrant, let us suppose the angle which are in second quadrant would be greater than 90 and less than 180. It means these angle would be obtuse angle. So sine of 120 would give you answer under root 3 by 2. Cos of 120 will give you answer minus 1 over 2. Now very first time you'll see this negative sign with cos, and the angle is in second quadrant. So tan of 120 will give you negative root of 3. Okay, so when we are saying all are positive, so sine positive mean sine at acute angle will give you positive answer. So sine positive, cos positive, tan positive mean we are getting some positive answer.
Okay.
When we say that in second quadrant cos is positive, so any obtuse angle from the second quadrant will give you positive answer, but with cos it will give you negative answer, and with tan it will give you negative answer. Okay, when we come to the third quadrant, in third quadrant only tan will give you positive answer, sine is negative and cos is negative. Likewise in fourth quadrant, when cos is positive, then other trigonometrical ratios will give you negative answer. Okay,
Oh,
so if you name the quadrant, I mean the first quadrant, second quadrant, third quadrant, and fourth quadrant, these are the fixed quadrant. You come from any direction. I mean, if you are coming like this, so you are moving anti-clockwise. So this would be the first quadrant, second, third, and fourth. But if you are moving from the clockwise direction, clockwise direction mean when you start your journey from x-axis and you are moving clockwise direction, then you would be in the fourth quadrant. So fourth quadrant, as I'm saying that the quadrants name are fixed. Either you are coming from clockwise or anti-clockwise. When in anti-clockwise, you'll be in first quadrant, and then in second, and then in third, and then in fourth. But when you are moving in clockwise direction, so you would find that you would be in fourth quadrant, then third quadrant, then second, and then first quadrant. So by changing the direction will not change the name of quadrant. So these would be the fixed quadrant.
okay.
All right, I'll select a question from exercise and we'll discuss the values.
Can I get my
Yes, given that cos theta is equal to 4 by 5 and theta is acute, theta is acute. Acute is an angle which would lie in the first quadrant. So you draw the quadrant, and in first quadrant make a triangle, in such a way that it would be a right angle triangle. It is cos of 30 cos of theta. So theta would be the angle, as we know that cos of theta is equal to adjacent over hypotenuse. So this side is adjacent and this side is hypotenuse. The given value is 4 over 5. So 4 is the value of A. So we write 4 in places of A, and 5 is the value of hypotenuse. So this is the value of this. The side opposite to given angle is opposite, which is unknown. So the first thing is, by using Pythagoras theorem, we'll find this unknown side. So as hypotenuse square is equal to the square of sum of two sides, hypotenuse is 5 square, and the side which is opposite to given angle is unknown. Um, I'll say that this is opposite square, and base is with 4 square. So it is 25 minus 16 is equal to opposite square, and opposite, I mean, when you take the square root of this, you will get 9, and square root, it will give you plus minus 3. As the side length is positive, so we'll take with root of 9 would be plus 3. Now we have all the three sides of given triangle. Once you have all the three sides, then you'll be able to find the parts. Like in part A, you need to find sine of angle theta. Yes. What is the sine of angle theta in triangle?
So, do we do opposite over hypotenuse?
Yes, and opposite
Like
is
3 over
3.
5?
Right. In B part, this is tan of angle theta.
So, we don't have to find the answer, we just write sine theta
Yes.
equals.
In the question we are asked find the exact value. Exact value would be in form of fractions.
Tan theta will be 3 over 4.
3 over 4, and in C part, as you can see that it is 2 sine theta into cos theta, and we have found from B part sine value is 3 by 5, and given in the question value of cos is 4 over 5. So when you simplify this complete, then 2 3s are 6, and 6 4s are 24, and 5 5s are 25. So this is the answer of C part. Okay, now D part, 5 over tan of theta.
5 over 3 over 4.
5, and tan theta value is 3 over 4. When you flip this fraction, and it becomes 5 into 4 over 3.
Yes.
So it is 5 4s are 20, so 20 over 3. D part. Now E part. In E part, it is 1 minus sine square of theta divided by cos of theta. Whenever you are given any trigonometrical ratio with the power, like sine square of theta, so sine square of theta will be treated as sine of theta whole square. Okay, this is very important notation. I mean, sometime student get confused with sine theta whole square. They write it sine square into theta square. Okay, so these two values are not equal. This square term or any power term would be the power of the ratio, not the angle. Okay,
So it
so
is
this is
the
the
power of the. So this means sine theta square equals to sine square in theta.
sine square theta. Sine theta square, no, sine square theta is equal to sine of theta whole square, and you can say that the power would be the power of ratio. trigonometrical ratio, not the power of angle, right?
Right.
Okay, so in this case, 1 minus sine square theta. So as we know that sine square theta means sine of theta whole square, and sine of theta value is 3 over 5. Then I'll take the square of this value and I divide it with cos of theta's value, which is 4 over 5. Now we need simplification. 9 over 25 over 4 over 5. So in next step I'll flip this denominator fraction. So when I take the LCM of this numerator term, 25 minus it's 9 and denominator becomes 5 over 4. So 16 over 25 into 5 over 4. 4 one time, 4 4, 5 one time, and 5. So finally our simplified answer is 4 over 5.
Okay.
Okay, now you try part F.
So we do 3 minus 5 over 3 plus 4 over 5. So would be 12 over 19.
Okay, it is final answer is 12 by 19.
12 over 19.
3 minus sine theta over 3 plus cos theta. So 3 minus it is 3 over 5 and cos theta is 3 plus 4 over 5. 5 3 is 15. 15 minus 3 is 12 by 5. 5 3 is 15 plus 19 by 5. So final answer is 12 by 19. All right. Question number 2 and question number 3. Again, these questions are like the given information is given in form of acute angle, I mean the first quadrant. So same process would be followed. So you just try these questions by yourself. Okay, before attempting the next question, there are some specific angles which we'll use frequently in this whole chapter, and by using the calculator you'll be able to find the answers, but it's better if you memorize those formulas, those values, angle values, and these angle values are very simple. These are not difficult. So let me draw the angle. This is the angle 0, 30, 60, 45, and 60. Finally it is 90. this is sine of an angle, cos of an angle, and tan of an angle. So angles and ratios. Sine of angle theta. So when you take 0, you can use the calculator and check the answer what will give you sine at 0 degree. It would be 0. And if I ask you to check what is the answer on your calculator of sine 30,
E,
it,
um, 1/2 half.
yes, it is 1 over 2. Okay, what is the answer of sine of 45?
2 root over 2.
2 over root of 2. Okay, so if I simplify this step, like the power of 2 is 1 and power of 2 in the denominator is 1 by 2. As both bases are same, so you know you subtract the powers. When you subtract the powers like this, you'll get 2 power 1 by 2, and 2 power 1 by 2 is root 2. This is what you have got, or you have got root 2 over 2.
I got root 2 over 2.
Okay, by using the same concept, you when you simplify it, you'll get this answer. Okay, 1 over root 2. So sine 45 will give you 2 root over 2, or even if you write from the calculator root 2 over 2, it's fine. But in the next step, by doing these few steps, you have to write your final simplified answer in this form. Okay,
Okay.
so it's better if you do the calculation and try to understand this by doing it directly. 2 power is 1, 1 by 2, so when you subtract half from 1, you'll get half, and half means square root, so you can directly write it. Okay, sine 30, sine 60,
So, 3 root over 2.
it's 3 root over 2, and sine 90,
90 is 1.
1. Okay, cos of 0 is 1.
Is 1,
Cos
yes.
30 is root 3 over 2. Cos 45 will give you this answer. Cos 60 is equal to 1 over 2, and cos 90 is 0. Okay, there is a relation, might you know this? Tan of theta is equal to sine theta over cos theta. Do you know this?
No.
Okay, so next time, this is a relation. Tan is a fraction of sine theta over cos theta. Just look at sine theta is opposite over hypotenuse, and cos theta is adjacent over hypotenuse. When you cancel hypotenuse with hypotenuse, you will get opposite over adjacent, which is the ratio of tan
Oh,
of theta. Okay, so if we are finding this tan of 0, we can think that tan 0 is equal to sine 0 over cos of 0. So from the table, cos z sine 0 is 0 and cos 0 is 1. So finally tan 0 will give you 0 answer. By doing such step for all the angles, like sine tan 30 is sine 30 over cos 30, sine 30 is 1 over 2, cos 30 is under root 3 over 2. When you cancel it, you'll get 1 over under root 3. This is 1 and this is under root 3. And finally, when it is tan of 90, so tan 90 mean sine 90 over cos 90. Sine 90 is 1, cos 90 is 0. In the denominator, we have 0. So such phenomena will give you something undefined. Okay, you must write this table and try to memorize the table. So this will help in simplification. You can use calculator, but if you memorize these values, you would find that you'll save time by using the calculator instead of you can directly write the answer. Okay, so question number 4. In part number A, find exact value when it is from the question. Like you need to write exact answer, then sine 30 is equal to 1 over 2, cos 60 is equal to 1 over 2, so final answer is 1 over 4. This is how you use the table and write the answer, or directly use the calculator, but do write the answer in form of exact. Maybe sometime calculator give you answer in decimal. In the
So
case
the
when in question you are asked to write answer exact and you write in decimal, then you'll uh, deduct the marks of exact answer. So sine square of 45 will treat it as sine of 45 whole square, and sine 45 is 1 over under root 2 square, and the square of this number will give you 1 over 2. So this is how you use the table to find the answers. Okay,
I do see.
yes.
um, would be 6 root plus 2 root over
Sine of 45 plus cos of 30, 1 over root 2 and under root 3 over 2. So 2 root 2 is LCM, so it is 2 plus 6 root. So this is the exact answer. When you use calculator, you'll get decimal of this part. Okay, so that would not be required. Okay, in the table we have considered few angles: 0, 30, 45, 60 and 90. It does not mean that you will not ask other than these angles. Maybe sometime you have to find the value of sine at the angle of 20. So all the angles other than these few angles, you have no way other than the calculator. Only by using calculator you'll be able to write the answer. That answer might be in form of fraction or in decimal. So the both type of answer would be acceptable. Okay. In circular mirror, we have learned that 180 degree is equal to pi radians, right?
is
Okay, so if we multiply this equation with 2, we will get 360 is equal to 2 pi radians. So these two are basic information, and we have learned that convert degrees into radians, and for such case we multiply degrees into pi over 180. Any angle in the form of degrees will multiply with pi by 180. If it is 30 degree, if you multiply it with pi over 180, after simplification you'll be getting this pi over 6 radians. So answer would be in radians. So at the same time we can also convert a radians angle into degrees by multiplying the radian into 180 over pi. If we have pi over 4, so by looking into pi we say that it is angle in radian, and if we multiply it with 180 over pi, so pi will cancel with this pi, and the answer after simplification would be in degrees, 45 degree. Next question is in the form of radians. So the table which we have learned, we can use this same table for degrees values as well, the radians value as well. Okay, we can say that this 30 degree is equal to pi by 6 radian, this is pi by 4 radian, this is pi by 3 radian, and this is pi by 2 radian. So in A part, when it is sine pi by 4 into cos of pi by 4, so by looking into the table, sine pi by 4 will give you 1 over under root 2, cos 1 by cos pi by 4 is also equal to 1 over under root 2, so final answer is 1 over 2. Okay,
So what did we do to the pi over 4?
pi over 4. Pi over 4, if you convert this pi over 4 into degrees, then you would find that pi over 4 is equal to 45 degree. So if you use calculator, sine of 45 or sine of pi by 4, both will give you same answer, 1 over under root 2 and 1 over under root 2. But for this your calculator mode must be in degree, and for pi over 4 you have to select radians mode. Okay, so as now your calculator is in degrees, the first thing is select your radians mode. Use your calculator, select the mode.
So, what did I put in my calculator?
Yes,
Uh,
how would you
One
convert degrees into radian on calculator?
people multiplied by pi over 180.
Okay, that's the manual method, but there is an option on your calculator. Press shift button and mode. Shift and mode. Okay, how many options have you got on the screen?
Got 8 options.
Okay, and do you find any option with radian, with number?
Yes, number 4, RAD radian.
Okay, press 4.
Okay.
Now your calculator is in radian mode. After converting the calculator in radian mode, then write sine pi over 4 and see what will you get.
I got 2 root over 2, which is 1 over root 2.
1 over root 2, so you'll get same answer. Okay, in the radian mode, if you press sine of 45, you'll get the answer that would not be equal to 1 over under root 2, so this answer would be wrong. Okay, in radian mode, so you have to be careful in radian mode and degree mode. When your calculator is in degree, then take the angle in degree. If your calculator is in radian, then you have to convert the degree and angle into radian, then apply it with sine, cos or tan. Okay, is it clear now?
Yes.
All right. Now attempt the other questions and or the parts from the exercise. Okay, the next concept of trigonometry is about the angle. We name the angles as journal angle, and the other thing which we'll learn, the basic angle. Journal angles are the angles which are measured along the x-axis. The very first thing is you'll measure the angle from x-axis and you move anti-clockwise. Okay, so these are the two main points for journal angle. Let's see. So this is x-axis, so all the angles will measured with respect to x-axis. If I draw a line, so any angle which will lie in the first quadrant and your direction is in anti-clockwise, and you put an arrow to show that you are moving anti-clockwise, so all the angles measured in anti-clockwise direction along the x-axis is called journal angle. So in this case, so you might have angle in any of the quadrant. If it is in second quadrant, so this angle is considered as journal angle. If your angle is in third quadrant, then you mention in the third quadrant with an arrow, and even the angle is in fourth quadrant, so when you started with the x-axis and move to this fourth angle, so this angle is considered as a journal angle. So all the angles which are measured from x-axis in anti-clockwise is called journal angle. Okay, next is basic angle. Okay, if you are in journal angle, if you are moving in anti-clockwise direction, your angle would be positive angle. Positive angle and negative angle means might be sometime you have got the answer in form of minus 60 degree. You can see that angle is negative. So in case of minus 60, your direction would be clockwise. You move clockwise along the x-axis just like this. This is x-axis. If you are in this quadrant and you are showing your direction with an arrow, so it's a clockwise direction. So clockwise direction means angle would be written with negative sign. So whenever angle is with positive sign, so direction of angle would be uh, anti-clockwise. If your angle is with minus sign, then direction of angle would be clockwise. Basic angle. Basic angle is always acute angle. This is called acute angle, and projection of angle will be on x-axis. The projection of angle will be on x-axis mean the shadow of an angle would be on x-axis, just like this. When we plot a line in the first quadrant, so the projection of this angle is on x-axis, and this angle is an acute angle. So all the acute angles along the x-axis are called basic angle. So if you have angle in the second quadrant, then the projection of this angle would be on the x-axis. There is another point. Basic angle will not show basic angle with the direction. I'll explain in different examples. Okay, when your angle is in second quadrant, so this angle is called basic angle because the projection, if you spot a light at the top of the angle, so you would find that your projection would be on the x-axis. If you have angle in the third quadrant and you spot a light at this point, so then you would find that shadow of this line would be on negative part of x-axis. It is x-axis. So this would be your basic angle. And in fourth quadrant, if we spot a light at this, then basic angle would be this one. So from all these four quadrants, we have learned that the angle with the x-axis in form of acute angle will give you basic angle. Okay, I suppose that basic angle is alpha. If basic angle is alpha, so in all the quadrants, when I plot the angles, so in first quadrant this is alpha, in second quadrant this angle will be alpha, in third quadrant this angle will be alpha, and in fourth quadrant this angle will be alpha. There is a note for this basic angle and general angle. You have seen that in first quadrant, when the angle is acute, we called it a general angle. But when we introducing basic angle, so in the first quadrant, angle is acute, angle is along x-axis, projection of this angle is on x-axis, so we called it a basic angle. So note is acute angle in first quadrant is basic and general both. So in first quadrant we'll have no discussion. We'll say that according to situation we say it's a general angle, we can also say it's a basic angle. But any angle which lies in the second quadrant, like I draw a line and I show that this angle is 120, it means general angle is equal to 120 because it is along the x-axis, it is moving in anti-clockwise direction, and from the concept of basic angle we know that the projection of this line along x-axis is this alpha. So we can find this angle by subtracting. Basic angle is represented with alpha and general angle subtracted from 180 it becomes 60. So you can see that this 60 degree is on x-axis and acute as well. So whenever you have angle along the x-axis and it is an acute angle, you call it as a basic angle. What happens if you use both angle for trigonometrical ratios? If it is sine of 120, your calculator will give you under root 3 over 2. But if you use basic angle with the same ratio, you'll get the same answer. Sine of 60 under root 3 over 2. Please confirm this answer on your calculator. Did you get the same answer?
And I'm sorry, the Teams shut down in the middle, so I just turned it on.
Okay. So now can you see the screen?
Yes.
All right. Let me repeat it again. Now, so we were about the basic angle. Basic angle is an angle which is along the x-axis, and all the angles are acute. To get the idea of this acute angle, we use this concept. The projection of angle will be on x-axis. If any angle is on x-axis and it is acute, we call it a basic angle. Then we write a note that acute angle in first quadrant is always called basic angle and general angle at the same time. After this, when we consider an example, 120 degree. 120 degree is an obtuse angle. Obtuse angle is an angle which is greater than 90. So when any angle is greater than 90, it would be in second quadrant. In
Yes.
second quadrant, if we use the calculator for the angle, sine of 120 will get under root 3 over 2. Basic angle is an angle which is along the x-axis and acute. So when you subtract this general angle from 180, you'll get this basic angle. 180 minus 120, it is 60. 60 is an acute angle, and acute angle means sine of 60 is giving you the same answer. Why both answers are same? Because when you start your journey from this point and reach at this point, so you will be on this line.
Yes.
Okay, but if you come from this point and move to this line, which is called basic angle, then you will be again at the same position. I mean, by coming from both direction, you will be at the same point. It means the answer must be same. Okay, is it clear?
Yes.
Okay, I want you to check what is the value of cos of 120 and cos of 60.
Do I have to turn it into radians because the calculator is in
Radian. Okay, convert into degree because we are considering the angle degrees in degrees.
-1/2?
Negative 1 over 2, and what is cos 60?
Is 1.
1 over 2. Okay, this is second quadrant, and we have learned that in second quadrant sine is positive, cos is negative, and tan is negative. Okay, so for the value of tan of 120 and tan of 60, we get this value under root 3. 120 is an clear angle to get the idea about the second quadrant. So any angle is in second quadrant with the tan or with the cos will give you answer in negative form. But in case of sine of 120 and sine of 60, we are getting same answer. And I told you that why we are getting same answer, because by coming on either side, I mean positive x-axis to 120 degree or negative x-axis to this 60 degree basic angle, you'll reach at the same point. That's why its answer is same. But in case of cos, when you start your journey from positive x-axis and reach at this point, you'll get minus 1 by 2, and minus 1 by 2 is in second quadrant. In second quadrant cos is negative, but when you take the basic angle, you'll get this negative positive answer. So the thing which I told you that coming on either side you'll get the same answer, that is not correct in form of cos and in form of tan. Question is, how would we understand this concept? So we'll say that from here we develop a relation. Cos of angle 120 can be expressed as cos of 180 minus 120. Okay, 120 from the angle, we figure it out the quadrant. I mean 120 is in which quadrant? Number 1. Number 2, in second quadrant, what is the sign of ratio? I mean we are taking ratios cos, so we know that in second quadrant cos is giving you answer in minus. Then cos of 180 minus 20 is equal to cos of 60. So cos 120 is equal to minus cos 60. When we have considered sine of 120 and it gives the same answer as sine of 60, and we can write them with equal sign because sine is positive in the second quadrant. Either you consider the general angle or you consider the basic angle, but in form of cos we know that for general angle in second quadrant cos will give you negative answer. How would we make this equality? We write cos of 120, and in case of 120 only, if you look at the angle 120, this 120 is angle 120 angle is at the position of this, and when you come from the other side and you covered an angle of 60 degree, so coming from negative x-axis or coming from positive x-axis, you'll reach at the same point. By looking into the angle you reach at the same time, but cos is in negative, cos is negative in second quadrant, so we equate them with minus sign. Okay, so when you
So
write
where does cos start from?
cos, when we say it is general angle, then it will start from this point. If we say it's basic angle, then it will start from this point. Okay, starting from this point and reaching at this line, or starting from this point and reaching at this line, the line is same. What is the difference? It's the sign, because in second quadrant cos will give you negative answer, so all you have to do is you'll put minus sign with the basic angle. This like this cos of 120, this is the basic angle, this is cos, so you'll put minus sign outside of the function. Likewise, if we say tan of 120 and 120's basic is 60, so we write tan of 60, and tan of 60 will write it with minus sign because in second quadrant tan is negative. Did you get it?
Yes, so if
Mm.
this line goes into the third quadrant,
Mm.
then we will have a then we will get a positive sign and a
Positive sign for tan, negative sign for sine, and negative sign for cos. And if we consider any angle in the third quadrant, let us suppose this is 210. The first thing is we'll figure out which angle is a basic angle. This angle is alpha is the basic with x-axis, and we are sure about that at this line angle is 180, and the line in the second quadrant is 210. So difference of 210 and 180 is equal to 30. So journal angle is equal to 210 and basic angle in third quadrant is equal to 30. So we will find tan of 210, sine of 210 and cos of 210. If you use the formula, then you'll find this is how you attempt. You'll think about the given journal angle 210 and 210's basic angle is 30. Then you write 30 with tan, you write 30 with sine, you write 30 with cos of 30, tan 30, sine 30, cos 30. Okay. Now we'll think about the sign, positive or negative. In third quadrant, tan is positive. Then we'll put plus sign with tan of 30. In second quadrant, sign is with minus sign. Then we put negative sign with sine 30 and negative sign with cos 30. Okay? Does it make some sense?
Yes.
Okay. In the third quadrant, if I consider one angle 315 degree, then I would write that journal angle is equal to 315. What would be the basic angle in
Then
fourth quadrant?
15 minus 270, so it would be
So which side is this a basic angle or this one is a basic angle? Question mark or tick mark?
below the x-axis, so the tick mark.
Yes, this is the basic angle. Okay, so this basic angle, when you take a complete round, the angle would be 360. You'll subtract journal angle from 360. So basic angle would be found 360 minus 315. It is 45 degree. So this is the basic angle. Now we think which trigonometrical ratio is positive in fourth quadrant. So it's better if you write A S T C. A is for first quadrant, S for sine is second quadrant, T for tan is third quadrant, C for cos in fourth quadrant. So in fourth quadrant, cos is positive. If cos is positive, then sine is negative, tan is negative. So from here, if I write cos of 315, then I'll think about the basic of 315. It is 45. When I write cos of 45, then after writing this, I'll think about plus or minus sign. Okay, sine of 315 would be equal to sine of 45. Tan of 315 would be equal to tan of 45. As cos is positive, then I'll put plus sign. As sine is negative, I'll put minus sign, and tan is also negative. Again, I'll put negative sign. Now, is it clear
Yes.
now?
Yes.
Okay. So, whenever you have any journal angle in second quadrant, so the basic angle would be found from like this. Journal angle minus 180 when it is in third quadrant. When it is in fourth quadrant, alpha is the basic angle. You'll subtract 360 minus journal angle. In second quadrant, alpha is the basic angle and you'll subtract 180 minus journal angle. And in the first quadrant, all the angles are journal and same angle would be considered as the basic angle. Is it clear now? If I consider question number 1 from the exercise, okay, for each of the following diagram, find the basic angle theta.
T minus 110.
So this angle is alpha. A part alpha would be found
T minus
180 minus 110 is equal to alpha. Okay, in B part this angle is alpha, basic angle.
360 minus 320. We do 360.
Hmm. If you complete one round either in clockwise direction or in anti-clockwise direction, so complete one round would be of 360 degree. Simple. And we need to find this missing angle. If you subtract 320 from 360, it would be 40 degree. Basic angle is always in positive form. You can find it by any method, but the first thing is figure it out that which portion is a basic angle, and then how would you get this basic angle. You can see that you have moved a clockwise direction, which would be with minus sign. So just forget this minus sign. Just think, if you take a complete round, it would be of 360. Subtract given angle from 360, you'll get acute angle. And that acute angle is along the x-axis. So we call it a basic angle. So basic angle in B part is this. In C part,
To 70 minus 200.
this is the way. How would you get this? General angle minus 180 for third quadrant. This is the third quadrant.
200 minus 180.
So it is 210. Basic angle mean 200 minus 180. So it is 20 degree. D part. In D part, you have complete one round at this point and then further this angle. So whenever you have any angle which is greater than 360, like in this part theta is equal to 500, 500 is greater than 360, then how would you get this basic angle? The very first thing is subtract 360 from the angle to get an angle which is less than 360. 140 will get.
Yes.
Okay, so this part of the angle is 140 from this point to this point. Basic angle is this. So 180 basic angle alpha, if I subtract 180 minus 120, I'll get 40 degrees. So basic angle is 40 degree. Is it clear now?
First, we subtract 60 from the 500 to get 140, and then we subtract
If I
140.
if I take an angle, let's suppose 420. Then what is alpha in this case?
So 20 minus 360.
Okay, 420 minus
And
360, it is 60 degree.
80,
This 60 degree,
180 minus
this 60
180
degree
minus
is this one.
60.
So you will think that if we start from this point and reach at this point, we'll complete one round of 360 degree. Anything which is greater than 360 and less than 420 will be the basic angle. So in one step we'll get the answer. If I write an angle 780 degree, then what is the basic angle alpha?
We subtract 360 from 400.
780. How would we get this basic angle?
Is 360.
We'll subtract 780 minus 360, and what do we get?
We get 420.
It's 420. Again, this 420 is greater than 360. So we again subtract 360 from 420 to get the answer. So it is 60 degree. Now this 60 degree is considered as an acute angle, and which would be in first quadrant. So we say that alpha is equal to 60. From this example, I just want to tell you that if you are getting any angle which is very big, you'll subtract from 360, and you'll keep subtracting 360 from the given angle until you'll get anything which is less than 360. Once you get the angle which is less than 360, then you'll be able to um, find the quadrant, and from the quadrant you'll write your basic angle. Okay, if I select an angle of 100 1230, so without this kind of graph diagram, so can you find basic angle of 1230? Theta is equal to 1230. Basic angle, what would be the basic angle?
Subtract 360 3 times, we will get 150.
So if we subtract 360, so minus 360 will get 870. Again 870 is a bigger number, so again we subtract 360, we'll get 510. Again 510 is a big number, so we subtract it from 360 again, minus 360, I'll get 150. So 150 is a figure which I can plot in the quadrant, so it would lie in the second quadrant. Once you have this angle in the second quadrant, then you'll able to find its basic angle. So basic of this angle would be 30.
So if they give us the basic angle, so then can we find the alpha angle?
Yes.
Gave us uh,
Now find the basic angle of 1470.
will it be 30? Mina? Sana, brother. पता है नूर के साथ कीबोर्ड यूज करवा रही
So, what is the basic angle of 1470?
I got 30.
30. Yes. So finally, when you subtract, keep subtracting 360, you will get at the end 30 degree. So 30 is the basic angle, which is less than 90. If I ask you to plot this for 1470, then 1470 means the angle would be in the first quadrant. 30 would lie in the first quadrant, and so if I want you to show all the revolution, then this is first, this is second, and this is third, and plus 30. For third revolution it become 1440. When you add plus 30 it become 14 and 70. So the complete general angle can be shown. All right, next
Why do we keep
question.
going anti-clockwise again and again?
Again and again to reach 1470.
Oh, okay.
Okay, by subtracting 360 you'll be able to get this 30 degree, which is basic angle. From that basic angle you'll show it on the diagram, and if you want to show the general angle on the diagram, then you have to show the revolutions, like 360's 3 revolution is equal to 1440, and plus 30 you'll get 1470. Okay, now the question is, few angles are in plus sign or few angles are in second with minus sign. Draw the diagram showing the quadrant in which the rotating line OP lies for each of the following angles. the first thing is we just need to show the angles. So in A part, as 100 is obtuse angle would lie in the second quadrant. So this is it. Just draw a line in second quadrant and draw in such a way that it looks that it is 100 mean a bit greater than 90 degree. But when it is minus 100, so minus 100 mean you start from the x-axis but in clockwise direction, and then you draw a line, and this would be minus 100. Okay, now for 310, 310 mean this is 270, and when you add 40 degree to this, so this becomes 310. What about minus 150?
Start clockwise from the x-axis,
Hmm.
and we will
It
find
would,
150 in the second quadrant, in the third quadrant.
yes, in the third quadrant, yes. 150, so this angle is minus 150. Okay, 400.
Start anti-clockwise, and it will be in the fourth. Because it's more than 360, it
Okay,
will be again in the first quadrant.
first quadrant, very good. And how much greater than 360?
Will be one whole round and 40 in the first quadrant again.
Yes, something like this. Okay, if you have angle in radians, so better to convert 2 pi by 3 by multiplying it 180 over pi in degrees, and it is 60, so 120 degree. 120 degree mean you can easily plot in the second quadrant and write in the form of radian 2 pi by 3, right? G part.
So if we change this into this, it would be 210
Okay,
degrees.
right.
So it would be third quadrant anti-clockwise.
Which quadrant?
So
In the third quadrant, and 210, which is 7 pi over 6. Okay, H part.
uh if 300 degrees, and we will go clockwise from
Clockwise.
first quadrant, and it will, and this will end up in this, yeah.
And the basic of this would be 60, and this is minus 300, so the basic angle is 60 degree. Okay,
Yes.
all right. This is a question. In each part of the question you are given the basic angle B and the quadrant in which theta lies and the range in which theta lies. Find the value of theta. Theta is the general angle. Okay, so basic angle is given. Like in A part, when basic angle is 55, and your angle lies in second quadrant, and second quadrant mean here you mention it, and then general angle from x-axis, and it moves in anti-clockwise direction, then you'll get it 125 by subtracting from 180.
So we have the basic angle and we have to find the alpha angle.
General angle, alpha angle is the basic angle.
Oh, the general angle. Oh. So in part B, it equals to 20 degrees in the third quadrant. So if we, does this mean it's 20 degrees inside the third quadrant?
Yes.
So if it's 20 degrees inside the third quadrant, that would make it 200 from the,
But this is showing that theta is minus 180 to 0. Minus 180 to 0 mean clockwise because angle is mentioned in negative sign.
so the general angle would be this
Okay, when you move clockwise
negative
from x-axis,
160.
minus 160. Yes, it is. So this is how you attempt the question. So these are two exercises for the homework, and inshallah I'll upload the test by tomorrow, and I'll inform you. Okay, then attempt, after attempting the test, upload on the Teams.
Okay. Okay.
Okay, all right, fine. Take care. Allah Hafiz.